So we're going to begin looking at solving systems by elimination. So the steps involved to solve by elimination is we're going to line up the like terms. So with substitution, how we did one equation next to the other, so we had two different kind of columns going. Elimination, we're going to have them lined up over each other. When we say like terms, we're meaning the x's are over the x's, y's are over the y's, equal signs over equal signs, and then whatever the numbers are lined up over the numbers. It could be in standard form like this, where it's x and y on the same side. We could have elimination where we have y equals 2x plus 3, and we have y equals 3x plus 4. This also would work for elimination. Everything's lined up appropriately. So that's step number 1. Step 2 involves us before we do that, finding equal coefficients on a variable. So once we have them lined up, we have to make sure that they have the same coefficient value. So it's a 2x on both, or it's a 5y on both. Once we do that, we're going to add or subtract to create 0. So if we have a 2x in both of our problems, 2x over a 2x, we're going to end up subtracting that so we can make a 0x and make it go away. This is where the system gets its name, elimination. We then end up solving, and then we use a bit of substitution to finish it out. So let's practice a few. First thing we check, x's are over x's, y's are over y's, equal sign over equal sign, numbers over numbers. We're all good. Now we're going to look for which variable has the same coefficient in front. Looks like both of these are 3y's. This is the one we're going to try to eliminate. If we look at this system, there isn't a good choice for substitution. 8 doesn't go into 3, 3 doesn't go into 8, 4 doesn't go into 3, 3 doesn't go into 4. So we wouldn't be able to avoid fractions with substitution. That's why elimination exists. Once we've identified which variable has the equal coefficients, we're going to look at their signs. I have a positive 3 and I have a negative 3. Because they're different, we're going to end up adding both of these equations together. We're going to take this part slowly. This is where the most mistakes happen in the elimination method. I have negative 8x plus 4x. So I have negative 8, excuse me, plus 4, that is negative 4x. 3 plus negative 3, 3 plus negative 3. That's 0y. This is what we need to see. We have to have something 0y, 0, one of those. If not, nothing in this problem is going to work. Switch colors where we want to. Equal sign still right where it belongs. 25 plus negative 17. 25 plus negative 17. That gives us 8. What's left over is a negative 4x equals 8. We divide both sides by negative 4, and x equals negative 2. Just like that, we have half of our answer, just like our systems before us. Now we have to use this to help us solve for the other one. We're going to choose either equation. doesn't matter which one, we're going to pick the one that looks easier. I'm going to pick the top equation because there's only one negative rather than two. I'm going to plug in negative 2 for x because that's what we just found. It gives us 16 plus 3y equals 25. We subtract 16. It gives us 3y equals 9. Divide by 3, and y is 3. Let's try that again. So in this problem, everything is lined up appropriately. X's over x's, y's over y's, equal signs lined up, numbers over numbers. Now we're going to pick one of our x's or our y's, so we're looking for equal coefficients. Looks like the x's have equal coefficients, so do the y's. So we're just, in this case, we get to make a choice. Which one do we want to eliminate? I'm going to choose to eliminate the 6's. So because one's positive, one's negative, we're going to add. 6 plus negative 6 is 0x. 8 plus negative 8 is also 0y. And 26 plus negative 28 is negative 2. This is kind of interesting. 0x, so that goes away. 0y, that goes away. So I just have a 0 is equal to negative 2. Well, that's not possible. So when we see something like this, this is a no solution system. If we had an infinitely many solution, it would have been negative 2 is equal to negative 2. But that's not what we have. We have this. That's a no solution. Alright. Double check. Everything's lined up. X's, Y's equals numbers. Yep. So here we have this. The 5's are the equal terms. So we're going to eliminate them. They are both positive. Because they're both positive, we're going to subtract. 5 minus 5 is what gives us 0, not 5 plus 5. This one's a little bit trickier, so I like to write it off to the side. I have a negative 3. I'm going to subtract a 2. Well, negative 3 minus 2 is negative 5y. The next two numbers, again, can be kind of tricky. 8 minus negative 22, so 8 minus negative 22. Well, these two become positives. That gives us 30. Divide both by a negative 5, and y is negative 6. We pick one of our equations. I'm going to pick the bottom equation. 5x plus 2y equals negative 22. Gives us 5x plus 2 times negative 6 equals negative 22. 5x minus 12 equals negative 22. Add 12. Gives us negative 10. Divide by 5. And x is negative 2. One last example. Everything's lined up. The x's have the same number in front, and they also have the same sign. They're both negative. When they're both negative, just like if they're both positive, I need to subtract. Same sign, subtract. So negative 6 minus negative 6 ends up looking like this, which creates the 0x that we need. Excuse me. Then 2 minus negative 4 gives us 6y. And then negative 14 minus 10 gives us negative 24. Divide by 6, divide by 6, y equals negative 4. Now we have to choose one of our problems to work with. Again, I'm going to choose the bottom equation. It does not matter which one you choose. I'm choosing the bottom equation because I see that the negative 4 and this negative 4 are going to interact to become a positive number. So in my mind, that's going to make it a little bit easier for me to work with. So I take the negative 4 times the negative 4, I get a positive 16. Subtract 16 from both sides, I get negative 6, x equals negative 6. So x is negative 1.